Hello and welcome, this is Safa. In this video, we're going to understand two of the most important parameters in control systems, the damping ratio and the natural frequency. We'll keep the natural frequency constant and observe how changing the damping ratio affects the step response of a second-order system. Okay, here first of all, I started by clearing the command window, workspace, and any open figures to ensure a clean simulation environment. And here, I define the system gain K as 1. And I set the natural frequency omega n to 3 radians per second. Okay, in this video, the natural frequency is the keep constant, so we can focus only on the effect of damping. And next, I define 4 different damping ratios. This value represent an undamped system, 2 underdamped cases, and a critically damped system. Okay, here I define the Laplace variable S and create time vector from 0 to 10. Second, for smooth and consistent compression. Okay, and here I open a new figure and enable hold on so that multiple responses can be plotted on the same graph. Okay, hold on. And here we have a loop. Inside this loop, I construct the second order transfer function for each damping ratio. Then I compute the step response numerically and plot it manually, ensuring that each curve is clearly visible. Okay, and finally, I enable the grid and label the plot to make the result easier to interpret. Okay, run. Here. Okay, let's analyze the result. The blue curve here, zeta is 0. You can see blue. Corresponds to 0 damping. It oscillates sinusoidally with constant amplitude and never settle. You can see that. The red curve represents a lightly damping system. You can see. It shows a large overshoot followed by decaying oscillation before settling at the steady state value. And orange curve has higher damping, overshoot is much smaller, and the system settles more quickly. Okay, and purple curve is the critically damped case. You can see here. Okay, it has no oscillation and reaches that steady state as fast as possible without overshoot. You can see. Okay, this comparison clearly shows that the damping ratio control overshoot, oscillation, and settling behavior, while the natural frequency determines the overall speed of the response. In the next video, we'll explore how changing the natural frequency affects system dynamic. And you can check the GitHub link for the full code. Thanks for watching.